When you think of peanut oil, fast food probably comes to mind. But Here and Now reporter Joanne Magley shows how some students from Embry-Riddle Aeronautical University hope their research with this cooking oil will lead to big changes in the field of biofuel.
When Allison West and Deborah Farrell aren't in the classrooms at Embry-Riddle, they're getting their hands dirty in the garage at nearby Larson Motorsports, where they're both interns. The students are developing a custom mixture of biofuel that can be used in Larson's jet dragsters.
We're taking the 100% biofuel and breaking it down into a B20 formula, which is only 20% bio and the rest of it's Jet A. So that's the part that we're really working on, is the experiment of that fuel.
Farrell and West are part of Embry-Riddle's Ignite program that encourages students to be involved in research. In a similar project last year, a graduate student led a team that converted cooking oil from the campus cafeteria.
The research started by using biofuel in lawn equipment used to mow the campus grass. When that worked, the students set their sights on jet dragsters.
The dragsters use 5,000 horsepower jet engines and go from 0 to 60 miles per hour in about 1 second. The alternative fuel was first tested on the Embry-Riddle sponsored jet dragster at a race this past spring.
We put it in the car May of this year at Orlando Speed World, and we saw that it did actually work. It did do what it needed to do, and it was comparable to Jet A. From here forward, we're trying to get the right air-fuel flow ratio and make sure that everything in the engine is doing what it needs to do to perform correctly.
Chris Larson is one of the co-owners of Larson Motorsports and has a unique partnership with the university.
Biofuel and Larson, it's an interesting combination because we do have an affiliation with Embry-Riddle Aeronautical University right here in Daytona Beach. And the biofuel that we're using here at Larson Motorsports is actually made by Embry-Riddle students that work here in our building every single day. So the very next thing for us is to continue the development of this fuel, not only for use in the cars, but also in potential applications like possibly ground applications, military applications, commercial power plants, and even, of course, turbine engines and aircraft.
West explains exactly what goes into making the right formula.
We take 40 gallons of raw peanut oil or already used cooking oil. We then add methanol and potassium hydroxide to it, let that dissolve, and we heat it up for 4 to 6 hours at 120 degrees. That allows the chemical reaction to take place and we're left with fuel.
The reaction that takes place gets rid of any contaminants, like all of the fat in peanut oil. Then the oil has to be cleaned.
We actually have to do what we call washing and drying the fuel. We put water into it very slowly and let just nature evaporate, just the sun evaporate all the water out of it. It also reduces the amount of contaminants in it and gets us to more of a raw fuel state.
Now that the students know their fuel formula works, they have great expectations for their future research.
We can reduce our emissions by, I think, 20% with the B20 blend that we have. So I think that's really exciting. And in aviation, that's a big deal, is the emissions and all that. So I'm really excited to see if it'll kickstart something in the aviation industry like it is in the auto industry, with people going green, so maybe we can reduce our emissions.
We hope that by 2015, Larson Motorsports will only be running biofuel that we make, which is pretty exciting. After that, maybe it'll become an industry standard. Who knows?
For Volusia Here and Now, I'm Joanne Magley.